Welcome to this video on ionic bonding. So if we just do a brief little review of ion formation, we know that cations are always those positively charged ions, and they tend to be metals. Okay, and they're positively charged because they've lost valence electrons. And in doing so, the number of electrons that they've lost is equivalent to the magnitude of their charge. Anions are nonmetals. They tend to be on the right-hand side of the periodic table, and they actually gain valence electrons. And when they gain those valence electrons, the magnitude of their charge is in the negative direction is the number of electrons that they have gained. And so we can take a look at the periodic table of ions, which is kind of a nice reference. Now we can just use a regular periodic table and know the overall trends, but this is a nice thing to refer to. And so we see everything in the first column is a +1 charge. Everything on the left-hand side of the stair-step line, you will notice all of these things over here are all positively charged. They're metals. Okay, so we remember back to just some basics on the periodic table. And everything right of that stair-step line, these are all negatively charged. These are going to be our anions, and those are our nonmetals. And we see that hydrogen can do both. A lot of times it tends to do this +1, which is why it's in that first column. And then we see some interesting things in the middle of this chart, and these are what we would call polyatomic ions. And so there's some interesting things with those. We have this chart to refer to, which is nice, or sometimes we'll have a list of them. And we see these transition metals. This is where it starts to get weird. We see that they can have more than one charge, and so we'll be addressing that as we go through and work through some of these bonding problems. So polyatomic ions, just for your reference, are covalently bonded elements, nonmetals, that have gained or lost electrons to become more stable in their overall structure. And so you can see here, I drew out the structure. You don't need to know how to do this yet. We're going to do this when we get to our covalent bonding. But this 2- charge on this sulfate, for an example, is representative of the 2 electrons that this structure had to gain in order to become stable. It was missing 2 electrons in the overall structure, and so we gain those 2 electrons, and that becomes an ion then. And then this can go through and bond ionically with other entities. And so what happens is once these ions have formed, okay, this is the big deal. The ion formation happens first. The ionic bonding happens as a result of positive and negative ions attracting to one another. And so I want you to think back to that electrostatic attraction, or Coulomb's law, Coulombic attraction. And if we have a positive entity and we have a negative entity, these are going to be attracted to one another. Okay, so we get an attractive force. And that attractive force is where we're going to see the ionic bond. Okay, so we see an ionic bond here between the positive and the negatively charged entities. Again, remember, 2 negatives, they're going to repel. 2 positives, they're going to repel. And so what it is we have a cation, or cation, that is going to be attracted to the anion. Now, how they actually go ahead and form these bonds, as far as the numbers of each ion, is what we're going to address next. And so here we go. We have these things that we call formula units. So in order to write the formulas for our ions, we are going to have to use the ratio of cations to anions. And so the cation plus the anion charge needs to be a net 0 charge overall. So let's give a couple of examples, okay? So in the first one, let's do something like sodium and chlorine, sodium chloride, table salt, okay? So sodium is a +1 ion, and chloride is a -1. Okay. And so when we put these together to form a bond, so maybe I'll just put a little plus there. If we have these individual ions, then what happens is they are going to form sodium chloride. It's in a 1-to-1 ratio, nothing else to worry about. We could also do the same thing with something like magnesium and oxygen. Okay, so magnesium is a 2+ charge, and if it's going to bond with oxygen or oxide, that's a 2- charge, we are going to get something that is MgO. The charges are the same magnitude in opposite directions, so they're in a 1-to-1 ratio. Now, if you were to write something instead, like Mg2O2, the standard convention is you must simplify, okay? So you must simplify to get to that MgO. Okay, what happens when they are not the same charge? Well, then we have to represent the fact that they aren't the same charge. So if we had something, and I'm going to kind of draw this over to the side a little bit. Say we had magnesium and we had chlorine. Okay, so we know that magnesium is a 2+ charge and chlorine is a 1- charge. So the question is, how many chlorines do we need to go with magnesium? Because the charge values, the magnitude of those charges, are not the same. So I'm going to show you the long way to do it, and then I'm going to show you a simpler way to do it. So the long way to do it is we say Mg has 2 valence electrons, and Cl has 1, or only needs to gain 1 valence electron. Okay, it has 7. So we can show this transfer of one of these electrons over to this chlorine. Now, we still have a second one that's on here. So this one has transferred. We should draw it that way. So we have to have a second chlorine. And then we have to transfer a second electron to another chlorine. Okay, so now the ratio that we have is Mg, we only have one of them, and we have 2 chlorides or chlorines. We'll call it chloride. We'll talk about the naming soon. Oops, I guess I probably wanted to make that look a little more like a lowercase l there. All right, now that might seem like you don't probably really want to have to draw those out each time. So I'm going to show you another way of doing this. The other way we call the crisscross method, okay? We say we're going to take the 2 here, not the charge. So if I have Mg 2+, and I have Cl, I'm going to actually write the 1 there, 1-. This crisscross method says we just take the magnitude, not the charge value, and I'm going to drop that 1 down below here, and I'm going to take the 2 and I'm going to drop it down here. Okay. And that results in Mg1, we don't write the 1, but then Cl2. And that crisscross method will do the same thing as the diagram did. The diagram is just showing that transfer of those electrons to form the ions, and then of course they're going to be attracted, oops, Cl2, sorry, I didn't get that one on there. They're going to be attracted because of those opposite charges. I hope that was helpful for you to just start your journey down the bonding road with ionic bonding, and we will discuss more of that in class.